Okay, so today I want to talk to you about basic electricity and need a very basic understanding of the lighting distribution system. So we're going to start with the middle of the outline where it talks about the distribution pieces. And of course, you start with any stage fixture. And the next thing in the relationship is the cable. And the cable ends in a connector. The connector is going to go into a stage circuit. So that those two connectors join up together and goes into circuit number 84. The circuits are the same as an outlet that you would find inside your house. The only difference is that there's many outlets on one circuit breaker, and usually in the theater every circuit has its own dimmer, which sort of behaves like the circuit breaker. So I'm going to show you. We leave from here, and I'm going to show you every theater is going to have dimmers. And it may be hard to hear me with the fan noise, but you open up this cabinet and you see there's all these individual little modules, and the modules can be pulled out, and you see there's two copper coils in there. That means that each one of these modules controls two separate circuits. So there's 48 modules in all, which means that we have 96 dimmers throughout the theater. So once again, the fixture plugs into the circuit, and the circuit is run by the dimmer. And then of course there's a control cable that goes from the dimmer to the light board, and that's how the light board is able to control the individual stage lights. So we will talk more in class about what the difference is between dimmers and circuits and the relationship between stage circuits and dimmers. But right now, what I want to do is I want to show you how to do some basic wiring that would be true for every repair situation. So here is the connector that was on the end of our light. And you notice this is called a stage pin connector. It's fairly specific to the theater industry. This particular one happens to be called a clear covered Bates connector. You don't need to know that. But stage pin connector, and this would be the same thing as like the end of a regular extension cord in your house. What I want to show you is that if you see on your outline, the wiring color matters. You'll notice that inside, it doesn't matter whether it's a stage cable or whether it's an electrical cord cable, there's going to be three different colors. There's a green one, which is here. There's a black one, which is there, and then of course there's a white one. And each of these do a specific thing. The black wire is the hot wire. So if that's, if you want to picture, it's not a very good explanation, but if you want to picture the electricity is going to the device, the switch, the plug on the hot line, on the black wire, and then it's coming back on this white wire, which is called the neutral or the common. And then of ground, of course, is the green wire, which keeps you from getting a shock if the ground wire is properly connected. And so what I want to show you is that there is sort of a method to the madness. If you look at our connector, you notice this pin that's isolated off by itself, and then you have the other two that are kind of close together. Well, this pin will always be the hot. So it's designed to be slightly isolated away from the other two. Any configuration where you have a middle pin, the middle pin will always be the green or the ground. And this is going to be true if you look at the back of a washing machine and you're having to reconnect a cable. There's going to be 3 screws in a row, sometimes 4, but always that one that's in the middle is going to be the green. The green wire is what you hook up first. You always hook the green wire up first so that whatever it is that you are working on will be grounded. And then you would hook up the white next, and the white goes by on the pin that is closest to the green. And the last thing you hook up is the hot wire. And then so if you were taking something loose, you would do it exactly in the opposite direction. You'd take the hot off first, then the white, and then the ground is what you would take off last. So just remember, the black or the hot wire goes off by itself on this isolated pin here. The green is always in the middle, and the white goes on the one that's left over. You'll find that the exact same thing is true whether you're doing a regular, this is what we call an Edison plug. It's actually a 3-prong 15 amp parallel blade, but everybody just calls it the Edison plug, thanks to our friend Thomas Edison. But if you look inside this connector, you will see that it has 3 colored screws. There is a green screw, which you notice is in the middle, and it also happens to correspond to that kind of D-shaped thing at the bottom of the plug, which is the ground. So green in the middle. Green means ground. You can see that it's green in color. Then the next one you would hook up is the white wire, and notice there is a silver colored screw. So the white wire goes to the silver, and if you'll notice, is the very biggest blade on the connector. And then last, there's a brass colored screw, and that's where the black wire would go. So black, brass, black, brass, that's how you can remember that. Silver kind of is in the, I don't know, white diamond family. There's no way to remember that, but just remember black goes to the brass screw, and it is the smallest pin on the connector. The exact same thing would be true if you were looking at a wall receptacle. Notice there's black or brass screws for the hot wire. There are silver screws for the white wire. And again, you can tell goes to the biggest blade and the smallest blade for the black. And then that leaves this ground pin. It's green, it's supposed to be green in color there all by itself, which goes to the ground pin. And the same thing would be true for a light switch or anything else. So let me tell you really quickly about this formula, and then we'll be done with this little video. But that formula at the bottom of the page, watts equals volts times amps. So we call that West Virginia, WVA, the West Virginia formula, and you'll notice that the pi formula is exactly the same. Those letters just are different letters for the same words. And the watts is based on what the watts of the light bulb are. So in the version of stage fixtures that we use, most of them use these 575 watt light bulbs. So that's the watts is given for you by the light bulb. So 575 watts equals the volts. The volts is always a given. Here in America, we have 120 volts. I know sometimes things say 110 or 115, but it's 120 volts in America. And then if you ever travel to Europe, they have 240 volts. So you need an adapter for your hairdryer or it will blow up. So the volts is a given, 120 always, times the amps. Now this is just something that you just always have to know. All of these circuits in a theater are most always 20 amps, always. There's never any variation on that. You may get into some weird squirrely situation where it's a very, 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 very old theater and it's something goofy, but it's always going to be 20 amps. The same is more or less true with your outlets in your house. Most of them are all wired to a 20 amp circuit, although there's also some variation there. So now it's just a matter of doing simple math. 575 watts, if you remember this from math class, 120 times 20 equals 240. And now, what do? You divide this by itself. 575. And then so if you divide this, you wind up getting a number that is 4 point something, 2 something something something. So, but you can't have a 0.2 something 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 of a light bulb. So what this is telling you is that 4 fixtures with 575 watt bulbs in them can be plugged into one circuit. So I know that looks kind of mathy and kind of heady, but it's really very, very easy. And like I said, that pi formula is exactly the exact same formula. And then that last one on your page is Ohm's law, and we will talk about that a little more detail later.